Okay, our last two sections that we have are for DMA 80. We have sections 8 and 9. Now, in the workbook, we have a couple of questions in section 9, but there are no questions for section 9 on the computer on MyLabs Plus. So what we're looking at here in section 9, this is DMA 80. Section 8 refers to, I'm going to list it as 8 and 9, but 8 is referring to using the quadratic formula. This is a formula that you need to know, and you will use it throughout when you go into Math 171, your other upper level math classes, you will be using this formula. The first thing when you use the quadratic formula is you make sure that your formula is quadratic in ax squared plus bx plus c. You'll identify what is the a, what is the b, what is the c. And then you're going to use this formula. You're going to use, let me change colors for it. You're going to use the opposite of b plus or minus the square root of b squared minus 4 times a times b. Everything is going to be over 2a. Now, one thing I really want you to pay attention to, if the a or the c are negative, everything is fine, just keying it in as it is. But if your b is negative, I'm just going to put here, if it's negative, I want you to be sure both here and here that if you're using your calculator, you put a parenthesis around the negative, because this would be the opposite of a negative would make that number become positive. And here, if you had like a negative 4 squared, it would become a positive 16, not a negative 16. So when you're using your calculator, it's imperative that your b, if it is negative, that you always remember to put a parenthesis around that. Okay, so as we get started with the quadratic formula, do you remember how back in DMA 60, when we were factoring quadratics, if we did the calculator steps and we could not find the middle number in the third column, do you remember how we said, oh, it's prime? So let me give you an example. If I happen to have this particular problem, I have 3x squared plus 4x minus 5 equals 0. That's a plus sign. Okay. So let me just review with you. Let me come to my calculator. Let me go to y equals. On the second row, I'm going to put my y1 plus x. And then on my first row, for this particular problem, I would have said 3 times negative 5 is negative 15. So I would have typed in negative 15 divided by x, second table. My middle number was a positive 4. So when I come to the third column and I'm looking for a positive 4, it would be somewhere in here, but there is not one. And when we could not find one, we said, oh, it's prime, we can't factor. Well, actually, yes, we can factor. We can factor by using the quadratic formula. Let me just recopy the formula here since it was on the previous page. So let me put it here so you can see it. What's going to happen is we're going to identify my A is a 3, my B is a 4, and my C is a negative 5. So what we're going to have is the opposite of 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 5. All of this is going to be over 2, and the A is a 3. When I do a problem like this, I go ahead and this is still just negative 4. 2 times 3 is going to give me 6. I'm going to write the plus minus, And then here, I'm going to draw my square root sign. Now this part, I'm going to key in on the calculator. However, I'm not going to use the square root sign. I'm just going to do 4 squared minus 4 times 3 times negative 5. So I'm going to do 4 squared minus 4 times 3 times negative 5. I'm only typing in what's under the radical, and that's going to give me a positive 76. So under the radical here is a 76. Now, just as we learned in this module, we can simplify the square root of 76. We're going to go to y equals. I'm going to clear both of these rows, and I'm going to do 76 divided by x raised to the index, which was squared. Second table, I'm going to look in the right-hand column and scroll down to see where a 1 would be, and we'll find there's not a 1. As we come up, our first pair of whole numbers is 219. So that means this is going to simplify to be negative 4 plus or minus 2 square root 19 over the number 6. So when you have a radical, still you have to simplify the radical as we've been doing so far. Now, in order to reduce the 6, the 2, the 4, we cannot reduce these unless all 3 have a common factor. All 3 of these numbers are even. I can divide 6 by 2 and I get 3. 2 divided by 2 is 1, and 4 divided by 2 is 2. So my final answer is going to be negative 2 plus or minus the square root of 19 over the number 3. Some of the problems that you're going to do and simplify are going to just give you a whole number answer, but then some of them are going to give you a radical in your answer. If you happen to have a negative under the radical, if you have a negative here, you would have to pull out the I for the negative 1. Okay, let's do 2 more of these. So for this one, we have x squared plus 6x minus 3 equals 0. My A is a 1, my B is a 6, my C is a negative 3. So I have the opposite of B plus or minus the square root of B squared minus 4 times A times C. Everything is over 2 times A. So again, negative 6 plus or minus 2 times 1 is 2. And we're going to key this in on the calculator. Okay, so we have 6 squared minus 4 times 1 times negative 3, and that gives me a positive 48. I'm then going to go to y equals. I'm going to do 48 divided by x squared, second table. I'm going to look and see if there's a 1. There's not. My first pair of whole numbers is 4 and 3, so it'll be a 4 that comes out, a 3 that stays under the radical. So if 4 comes out, the 3 stays underneath. So negative 6 plus or minus 4 square root 3, everything over 2. At this point, we look to see if we can reduce, and if all 3 of those have a common factor, and they do, 2 goes into all 3. 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 6 3 times. So my final answer is negative 3 plus or minus 2 square root 3. I do not need to put over 1. And one thing I want you to pay attention to when you're on the computer, you will find that there is a key that has both the plus minus sign as a little feature that you can choose on the little keypad that'll pop up. So you may use that feature. There's a little button. So I just want to be sure you realize you can do that button and not have to type it 2 times, once with the addition and once with the subtraction. I did want to give you one that was a little more complicated. So here's one that was a little more complicated. If you are given these two binomials equal to 1, we can't do anything until we have our equation in this form. So what that means is I have to FOIL and go through that whole process. So 2x times x is 2x squared. 2x times 2 is plus 4x. Negative 2x times x is minus 2x. Negative and positive is negative 4. And then this 1 on the other side, I would subtract 1 and equal to 0. So I would take the 1 and move it over. So now we have 2x squared. These two terms combine and give me a positive 2x. These two terms combine and give me minus 5 equals 0. So now I can identify my A as a 2, my B is a 2, and my C is a negative 5. So we have the opposite of 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 5. Everything is over 2 times A. So negative 2, 2 times 2 is 4. And let's use our calculator. So we have 2 squared, 2 squared minus 4 times 2 times negative 5. And that gives us 44. And when we go to simplify 44, we do 44 divided by x squared, second table. The 1 would be here. My first pair of whole numbers is 2 and 11. So that's going to factor out to be 2 square root 11. This one, when we further simplify, 2 goes into 2 once, 2 goes into 2 once, 2 goes into 4 twice. So we have a negative 1 plus or minus. I have to have this one. This one I do not need necessarily because I still have the square root of 11 and then everything is over 2. Always be sure this line, actually when I do this, I click the fraction key first before I start typing in the numerator and the denominator on that. And the very last thing I wanted to show you, in section 9, we talk about radical functions. I'm going to give you an example of what you're going to be looking at with radical functions. With a radical function, we're looking to find the domain of a relation. Remember, the domain are the x values. And when we do the x values and write the domain in interval notation, we always list it from small to large. If something is equal, we use square brackets. If we have infinities, here if we have a solid circle on the graph or an open circle on the graph, solid means it's equal, open circle means we use parentheses. So what's going to happen is you will have an equation that may look like this. You will have, say, f of x is equal to the square root of x minus 5, and we want to determine the domain and write in interval notation. So what we're looking for is the domain. What we're going to do is we're going to go to y1 on our calculator, and we're going to type that in. We're then going to press graph, the button for graph, and we're going to make sure we're at zoom 6 to view it. And then to verify what we're looking at, we're going to look at second table. So let me just put these little notes up here, second table, and we're going to look for when y is equal to 0. So let's start with this one. If I come to y equals, I'm going to clear. I'm going to do second and my square root symbol and type in x minus 5. I then press graph, and if I'm not at the standard view, I would do zoom 6. This one is at standard view. I don't usually try to count the tick marks, but you can tell it starts at this point and then it goes off the page. So the first left side is going to have a number. The right side is going to be infinity. To make sure we can determine what the number is, if you go second table and you look when there's a 0 for the y, we can be sure we have that precise number. And in this case, it's the number 5. Okay? So my domain for this particular one would be, it starts at 5 and it goes to positive infinity, and we would use a parenthesis after that. Let me give you another one. Let's say we have h of x is equal to square root of 6 minus 2x. And up here, let me just sketch a graph because it was like it started here and then it went off the page. Or actually, I'll do it in green. And then when I do the one down here, we'll look at this one. So 6 minus 2x. So if I come here to y equals, underneath, I'm doing 6 minus 2x. Graph to view it. Now this one you notice is coming in from the left-hand side, and then it's coming over to this point. So small to large, this side is going to be negative infinity, and it's going to go up to a finite point. So this one, the graph, when I look at it, is going to come in like this. So my domain on the left side, actually, on the left side, we use the parenthesis with the negative infinity. It stopped at a certain point, and let's figure out what that number is. Second table, and I want you to look for the 0 in the y column. It stops at 3. And let me give you one last one. And this is one where you'll actually have to do a calculation on your own longhand. This one's g of x and the square root of 3x plus 2. And let me do a little graph here so we can see what this one looks like. Okay, so 3x plus 2. Here, underneath, we're going to do 3x plus 2. So when we look at the graph, we see that it starts here. Now that's not actually at a specific point, but we know that it goes off to the side. It's not at a whole number. So let me go to the table, and as I come to the table, you'll see I don't have a 0 here. So for this one, I've got to do a math calculation to get that exact number. So what we're going to do, because like I said, ours for this one appears something of this nature. So I'm going to have to take 3x plus 2, set it equal to 0. I'm going to move this over, and I'm going to solve for x, divide both sides by 3, and I get that x is equal to a negative 2/3. So in this scenario, when I'm looking at it, it's going to start at a negative 2/3. It goes off the page, so that's positive infinity, and then use a parenthesis around the end. Okay? So that's what you're working with in the radical functions.